Hi, I'm Nathan from Pi3G and today I'm going to show you how to use the Coral AIY Maker Kit. We will learn how to set up an image classification AI and an audio classification AI on a Raspberry Pi 4. Let's have a look at the setup first. You can buy the AIY Maker Kit at our store, and on the store page you find links to all the resources that you need. The kit contains everything that you need to follow the examples, including a Raspberry Pi 4 and a Coral USB accelerator. As always, I will put all the links that you need in the description below. Download the custom image from the AIY Maker Kit website and flash it onto your Raspberry Pi. If you don't know how to do this, we have a video that explains the Raspberry Pi imager in detail. In the imager, select the AIY Maker Kit image under the custom images. You might also want to set up your Raspberry Pi for headless use, so check out the advanced options. After the image was flashed to the SD card, it's time to assemble the hardware. Start by plugging in the SD card into a Raspberry Pi's SD card slot. Then connect the Raspberry Pi camera, which is included in the kit as well. Click the link in the top right corner if you are not sure how to do that. The next step is to connect the USB microphone and the Coral USB accelerator. Now you can boot up your Raspberry Pi and log into it via SSH or connect to it via mouse, keyboard and monitor. The AIY Maker Kit website contains lots of examples like image classification, audio classification, pose identification or object detection. Let's start with an easy example for image classification. Open a terminal and change into the AIY Maker Kit directory, which contains all the example and code that is required for the AIY Maker Kit. Run the run tests.py Python script to make sure that your hardware is set up correctly. If you are getting an error, you should check the connection of your camera or USB accelerator. To train our image classification model, we need to collect some training images. In the AIY Maker Kit-examples directory, create a file called labels.txt, which contains the labels of the objects that you want to classify. The first label should always be background. In this example, you can choose 3 to 9 objects. Save and close the labels.txt file and then open a terminal and change into the AIY Maker Kit-examples directory. Prepare your objects and make sure you have some good lighting conditions. Then run the collectimages.py script to capture the training data. For each object, press the corresponding label number to take an image. The images will be saved in separate folders. It's advisable to take 10 images from different angles for each object. Press H to see the label numbers, and to quit the program, press Q. When you're done, run the labels.py script with the option -l labels.txt. The model will be trained and is now ready for testing. Run the classifyvideo.py script. It will display a video stream from the Raspberry Pi camera. In the top left corner, you can see the prediction of the model and the confidence value. Let's check out how audio classification works with the AIY Maker Kit. Open a new terminal and run arecord-l to verify that the USB microphone is connected. Then change to AIY Maker Kit and run the testmic.py script from the scripts directory. This will record sound for 3 seconds and output a file called test.wave in the scripts directory. Listen to the file, and if you need to increase the volume, run the command alza-mixer and press F4 to increase the sensitivity of your microphone. Then it's time to capture the training data. Go to the Teachable Machine website where you can capture the training data and train the model. First start by recording 20 seconds of background noise. The input will be split into 20 1-second long samples and should contain silence as well as some random talking. Add a new class for each voice command that you want to train. Hit the record button and say the command twice in 2 seconds, but make sure to be silent at the 1-second mark. Press extract samples if you're satisfied and change your pronunciation or tone between each sample. It's always good to capture equal amounts of data for each class. Once you're done, press train model. Depending on how much data you used, the training will take 10 minutes or longer. If you want a more robust algorithm, you should record different people in different surroundings. When the training is done, the website shows a live preview of your model. You can check out the performance and make some changes to the training data. In my case, the model was unable to differentiate lights on from lights off. Hence, I renamed and re-recorded the commands so that they would be easier distinguishable. I retrained the model, and after I was satisfied with the results, I ran the test script. The test script allows you to do whatever you like with the prediction of the model. For example, you can toggle a LED or a camera. So that's it for today. If you enjoyed the video, then make sure to leave a like and subscribe to our channel, as we will post videos like this on a weekly basis. Also, check out our store by Zero to pick up everything you need for your Raspberry Pi projects.